Exercise 4.1 Partial Fractions. Resolve into partial fractions. Question number 2. X minus 11 divided by x minus 4 into x plus 3. This is the given rational fraction. In this rational fraction, denominator factors are linear. They are linear factor because their degree is 1, individually having degree 1. X minus 4 is the linear factor and x plus 3 is also called as linear factor because both factors having exponent variable having exponent 1. So for linear factors, if linear factors are present in denominator, we will write the partial fractions like this. X minus 11 over x minus 4 into x plus 3 is the actual fraction, simplified fraction, and we will suppose that its first partial fraction will be a over its first factor of denominator is x minus 4. We will write here x minus 4 plus second factor with supposing numerator b over x plus 3. If linear factors are present, then we will write here plus simple a and b. Now this is equation number 1. X minus 11 over x minus 4 into x plus 3 equals to a over x minus 4, then plus b over x plus 3. This is written as equation number 1. Now we will multiply the LCM of this equation, which is x minus 4 into x plus 3, and multiply each term by its LCM. So by taking LCM of equation number 1, we get x minus 11. Here x minus 4 into x minus 3 will be multiplied and will cancelled. So we get only x minus 11 here on the left side. On the right side, this term will be multiplied by x minus 4 into x plus 3, and x minus 4 will be cancelled out. We get only a into x plus 3 plus b into x minus 4. Here x plus 3 will be cancelled out. This equation will be known as identity. It is identity, so we will write here I, capital I. Now put x plus 3 equals to 0. We will write here one factor from the denominator equals to 0. This is known as zeros method. Zeros method is useful for linear factors mostly, and we can get the value of variable easily. X plus 3 equals to 0. This implies x is equals to minus 3. We will put the value of x in identity. This is identity. We will put the value of x in this identity. And we get minus 3 for x and minus 11. Minus 3 minus 11 equals to a into minus 3 plus b into minus 3 minus 4. Now by solving this side, we get minus 14 is equals to 0. This factor becomes 0. So it is known as zeros method. Plus in each value, by putting in the identity one by one, each factor of denominator equals to 0. We get one term equals to 0. Always we get one value of supposing numerator, and all other values will becomes 0. So minus 14 is equals to 0 plus b into minus 7. Minus 14 is equals to minus 7b. So b equals to 14 by 7. This implies b is equals to 2. This is the value of b. And now we put here x minus 4 equals to 0 according to zeros method, and we get x is equals to 4 in identity. We will put the value of x equals to 4 in identity again, and we get 4 minus 11 is equals to a into x plus 3 plus b into 4 minus 4. minus 7 is equals to 7a plus 0. For this time b will becomes 0. 4 minus 4 equals to 0. Now 7 minus 7 by 7 is equals to a, so minus 1 is the value of a. B is 2 and a is minus 1. We will put these two values in equation number 1. This is equation number 1. In this equation there are opposing numerators a and b. Now we will put the actual values of a and b here, and we get x minus 11 over x minus 4 into x plus 3 is equals to minus 1 by x plus x minus 4 plus 2 over x plus 3. Minus 1 is the value of a, so we will put here minus 1 for a and 2 for b. If we want to arrange the terms according to standard or simplified condition, we will write here two positive term at the first place, 2 over x plus 3 minus 1 over x minus 4. So this is the final answer, and these two are the actual partial fractions of this simplified fraction.